Hello, today we are going to talk about the Qt framework and how we can use it from the Java programming language. So for that, we search Google for Qt space Java. It offers us the following results. So it says that there is a software named QtJambi, community maintained open source project that provides Java language bindings for the Qt functions, properties, API, classes, etc. So there is a tool that looks at the C++ header files, so .h files from the Qt framework, and outputs JNI, so C++ source code that's then compiled into JNI, and then Java files, which are going to be compiled into a jar. So this is the native jar, and this is the jar over a package from the Qt framework. It does support signal slots from C++ Qt, meta object, Qt style internationalization, Qt style graphical user interface controls, layouts, containers, interoperability from Java to C++ and back, QML, etc. Okay, and before 2009, it was maintained. The QtJambi project was maintained by Trolltech together with the rest of the Qt framework. Then, after Nokia purchased Trolltech, QtJambi became an open source project maintained by the community. Here, this has also been discontinued, and the current version is maintained here at github.com omics visualization QtJambi. Okay, so the Qt framework offers graphical user interface framework for building cross-platform applications and other frameworks, other libraries for building non-graphical user interface applications such as networking, SQL access, image manipulation, XML, JSON, thread management, etc. Okay, let's go for the official GitHub webpage of QtJambi, which is this one. There's a QtJambi. Where are you? Okay. So it says that it has bindings for Qt 6 for the latest Java JDK versions. So again, it looks at C++ header files, emits code, builds two types of Java jars, and we'll look at those. So QtJambi is available for Java 8.11 or higher, Qt 6.5. I do not want to build this thing from source. I want to use it, so I can use it either if I am using Maven. I use such a XML snippet. So Qt version could be 5.15.16 or 6.5.2. So let's try to use 6.5.2. We can download the jar files from Maven Central Repository. So 6.5.2. am I? Okay. This is how a Hello World application looks like. io.qt, because the official website of the Qt framework is q.io. And then widgets, because we want not to use QML but Qt widgets. These things are boilerplate: Q application shutdown, Q application initialize. This is a Q message box of type information, and then we want to compile this thing. Okay, so let's try to run this example. So we need a Java. We need to run the Qt installer to get the version of Qt that we're going to target, which is 6.5.2. So let's go there first. Let's open the Qt online installer. Okay, it asks for an account. Let's see if I remember my account. Okay, I have read and I agree. I'm an individual. Next. Network error. Okay, help us improve by enabling, yes. C:\\Qt, so this full path for the directory does not contain any spaces, really important probably. Custom installation, yes. Don't do that. No associations. Let's see. So it recommends that I install Qt Design Studio. No. It selects to install Qt Creator 11. Okay. Debugging tools for Windows. CMake Ninja. This is okay. Let's see if it has Qt 6.5.2. Okay. I don't want WebAssembly. I don't want WebAssembly. I don't want ARM. I don't want MinGW. So I'm just using MS Visual Studio. No Android, no sources, no Qt Quick 3D, no debug informations, 10 gigabytes, Qt Quick Timeline, maybe. Active Qt for decom, so no. Qt 3D, no. What else can we remove from here? Qt Quick 3D Physics. Okay. So 2 gigabytes. So this is what I'm going for. No Qt Design Studio. This is for designers, not for developers. I'm using the latest Qt Creator, which is the integrated development environment. then I've selected Qt 6.5.2, but just the relevant parts. So just Windows desktop parts, not ARM64, not MinGW, not Android, not sources, not PDB files. Next. I agree. Next. So start menu. Next. UAC, user account control prompt. And I'll pause it a bit and be back. Okay, so the Qt online installer has finished installing. Let's go finish. So it says that in order to execute the example, you need a platform dependent, so in my case Windows 11, binaries of Jambi. For Windows, that would be QtJambi native Windows x64652JAR from Maven Central Repository. That should be available in the Java class path. And we also need Qt. So we've used the Qt Online installer to install the Qt framework in c:/Qt, the directory. I'm using the same version for QtJambi and Qt 6.5.2. The location of Qt should be known by Java, either by using java.library.path or the path environment variable in Windows. Like this. Okay, let's get QtJambi. How do we get the listing? I'm not sure how to use this thing. Just a second, let me get at the downloads location for QtJambi. Okay, so it says that the QtJambi modules are listed here. And this says that the latest version of QtJambi for Qt version 6 is 6.5.2. And all of the links point towards maven.org. So Essentials Qt Core GUI widgets, not dbus, no networking, not QML, not quick controls, not test, not Bluetooth, not charts, not concurrent, not help, not OpenGL widgets, multimedia widgets, near NFC, positioning, print support, etc. So in fact, we only need the first download, the first part. So Qt Core, Qt GUI, Qt widgets. That's QtJambi.jar. So let's download this one first. Where is the button to download? Okay, so this guy. Let's put it in where? Let's make in here a directory. Today's day. Okay, so we have QtJambi.jar. We need QtJambi native. This guy. So this is cross-platform. This is platform-specific, Windows or Linux 64-bit. Versions 6.5.2. This guy. Save. There's a Java part and the native part. Okay, so let's put the documentation on the right half of the screen. Let's get the Orthodox file manager on the left half of the screen. So we're in today's directory. We want a test.java file. Shift F4, Control V. Okay. Should have this content. Trailing new line. PowerShell. What is this? Okay. So 652 is the correct version in the examples and what I have downloaded. So this thing should work as is. Java C is not recognized. I did not install Java yet. Java.com, what is that? Where are the downloads for Java? Just a second, let me find out where are the downloads. So there's SE20 back to version 7. JDK 20. Okay. Windows zip this guy. Let's see if it works or not. Okay. So we have in here the entire Java development kit, so the SDK software development kit for Java version 20. I extract it. Okay, Control X, Control V. This is an empty directory now, so let's delete it. It looks like this. It says that could not find the Java compiler. So let's put this directory into the environment variable path. for my user. So the path now also contains the directory where I have unzipped the JDK. Okay, let's open the editor again. Okay, back to the documentation. This thing. Okay, so now it has found the Java compiler javac.exe into this directory, which is part of the environment variable path. It has found QtJambi 652.jar in the current directory. It has found test.java in the current directory, and it has created a class file. So a compiled Java file test.class. Okay, and now we want to run that thing. And we want a command line like this. So the path is 652, like this. Java -cp jar, and then the current directory part of the class path. And then Java library path should contain the Qt DLLs, Qt framework DLLs, and then test.class. And then finally it goes hello world, okay. Let's see if it runs faster the second time around. Yep. Way faster. So the first run was way slower, and the second and third run were way faster. Okay. What else can we do with this thing? So let's put the command lines in comments. So this is the way to run, and this is the way to compile. Okay. So the package is io.qt.widgets, and then it has included all of the exported classes from there. Okay, so we have managed to test that QtJambi is working okay, but with a very minimal application that just shows a message box. We know how to compile it, we know how to run it. We need to do 3 more things. One of the things is to generate UI files using QDesigner, and then to convert those using QtJambi UIC into a native Java file, source file. The other thing is that we need a Java integrated development environment, And then we can use QtJambi also without .ui files by creating the UI straight from writing Java source code. So let's do that. So first of all, we need a Java IDE. This guy. We need Java Community, IntelliJ IDEA Java Community Edition. Where is that thing? Let me find out where it is. So it's under other versions, Community Edition, Windows x64, this thing. I'm going to use the installer, so not the zip file. We're waiting for the download to finish. Run the installer for IntelliJ IDEA Community Edition. UAC prompt. Where does it install? The correct directory. Great. Next. Desktop shortcut. Path variable. Open folder as project. File associations. Next. Start menu. This is the NSIS installer framework from the former Winamp media player. Okay, so we have three directories that want to be part of the path environment variable. One is the directory that contains QtJambi things. Then there's the bin directory from the JDK. And then there's the bin directory from Qt, the Qt framework. So one directory is this one. Let's create a directory for QtJambi. Okay. And the other one is c:\qt. This directory. So run IntelliJ IDEA Community Edition. I confirm. Okay, so I've started the IDE. Let's go new project. Where do I put them? Tilde on Windows. That's interesting. So let's use the JDK from here. Language Java. Does not matter the build system. Let's make the projects directory this one. Maven archetype empty project. Let's see what it creates. So it creates a src directory and a main.java, which prints something to the standard output. Okay, so I have created using IntelliJ IDEA a new Java project. I have replaced the default contents of the only Java file, which is main.java, with the sample that we have used previously to validate that QtJambi is working okay. And now we have added QtJambi to the external libraries. So that's either from here and then project structure, or from the main menu and then project structure, project settings, libraries. I have added the directory, this one, so directory of QtJambi. It saw two jar files which are now visible and available to the IntelliJ IDEA project. There's no more errors. There's a ton of classes available in the package. Okay. So let's see eventually if the debugger works. Start with the debugger. So I have the firewall enabled. Let's disable all firewalls. This thing. Off, off, and off. So for all of the three Windows Defender firewall with advanced security profiles, I have disabled the firewall because this machine is behind network address translation. It's a virtual machine, so you cannot really connect to it, neither from other computers than the hardware computer, nor from the internet. Okay. Okay. This application should not work because A, it has found the path for the Java JDK, did find the path for QtJambi, did not find the path for Qt, so this should not work, should raise an error. But still, let's run it with debugger. Okay, so where is the evaluation? How do we step over this thing, F8? Okay, and this throws Java exception that library qt6core.dll was not found in Java library path. So the Java library path contains what we specified as the JDK. Then some made up thing. Then the directory that we have added as external libraries. And these things, I do not know what they represent. Cannot type. Okay. Now it starts to make sense. So this is the path environment variable. And this is where it searches in. So this, I guess, it's made by the IDE, Integrated Development Environment. It has put the bin directory of the JDK that's used by the current project as first in path. Then this thing is this thing, so the path environment variable. This is the list of all of the libraries. This is the current directory in order to find the .java files from the current directory. So I guess I need to add the Qt framework bin directory to the environment variable of path of the current user. So let's edit the environment variable path. This thing, so we'll need to add the path where we installed Qt. So these are the Qt DLLs. It requires Qt6 base, Qt6 core.dll, this guy. Okay, so this is the directory. We'll put it on the third position. Okay. On the second position, there's the JDK bin. On the third position, there's the Qt bin directory. And the other directories IntelliJ IDEA knows about because they have been added as external libraries, both the JDK and the QtJambi. JDK is also available from the path environment variable. But it seems that IntelliJ IDEA has removed that from the search path because it's already in the search path, the bin directory of the current JDK. Okay, so now just running the debugger again should work correctly, if it knows how to refresh the path environment variable. If not, I'm going to restart the integrated development environment. Step over and says the same thing, so we need to restart the IDE. Are you sure you want to exit? Exit. How do we start IntelliJ IDEA? This thing. Okay, it's loading the last project that was loaded, which is our project. Interactive lesson available. Okay, let's skip for now. Run the debugger again. Step over F8. And it successfully went from the source code line 4 to line 5. Okay. Do we have step into? Step into. It's going to decompile qmessagebox.class. Okay, let's see that. It doesn't wrap lines, which I do not like. So where are the settings? Here. Wrap. editor wrap. Soft wraps, probably this guy. Okay, so I do not want the scroll bar that scrolls from left to right. Okay, so we're inside the Q message box. And the Q message box has the method information. So here, let's make more room. So this is inside of the platform agnostic part, the part that the QtJambi.jar, that a jar that runs correctly both on Windows and Linux. So not on the platform specific one. And then it goes return information. So this is an overload, which then goes Q message box standard button resolve. Which converts, what does it do? An int value into a standard button. Step into, and we're at QtJambi library utilities initialize. So this is the overload for the method information. Returns a standard button, so returns if the message box has been closed by Alt F4, Ctrl Escape, clicking on the close button or clicking on the OK button. Okay, where are you? Information, native, widget, PTR, cref, qstring, cref, qstring, qmessage box, standard buttons, qmessage box, standard button. Okay, and it's waiting forever because it has showed the message box. Okay, let's look at the call stack. Where is such a thing? These are the threads, and this is the call stack. So the first placed in the call stack is the entry point of the executable, the main static method of the main class. Then there's qMessageBox.information, the method, and then its overload. So this is a secondary and this is a primary probably. The method with the most number of parameters, which in the end goes into the native DLL, which is Qt6. One of the Qt6 DLLs from this directory. Okay, so this is where the Java call stack ends, and from underneath this thing there's a C++ and a Windows native call stack. Okay, so information native Q widget, PTR, cref, QString, cref, QString, QMessageBox standard buttons. So this is using the Java JNI to go to the C++ source code that resides in the other jar file, so in this jar file, which is platform specific, Windows AMD 64 in my case. Okay, so let's close the message box such that the debugger can continue. Step over, and we're back in main, so just one line in the call stack of the current thread. Okay, step over, step into shutdown, which calls the method shutdown, the static method shutdown from another class. QThread is surfaced in Java from Qt core. There's documentation based on the Java objects hierarchy packages. I'm not sure that there's Java doc. Okay, where are we? Up.thread. Step into loop level. Okay, where are we? QThread.class from QtJambi.jar. Garbage collect. Okay, and the process has finished. Exit status 0. Great. Close other tabs. What's next? So now we have an integrated development environment where we can run anything. Let's run a couple of examples and see what happens. How do we create another package, another project? Let's put this under version control and then we'll edit the same project over and over again. I'm going to use the portable Git version. So temp, this guy, Control X in here, self-extractor, correct directory. Okay, git cmd. Git init here, git GUI. Okay, let's see there's a pre-existing git.gitignore file. How does it look like? Maybe the guys from IntelliJ IDEA know best. So it ignores IntelliJ IDEA, Eclipse, NetBeans, Visual Studio Code. Looks okay to me. So I'm just going to add all of the files that are not already git ignored. LF will be replaced by CRLF. No, I do not want such a thing. Let's create a .get attributes file. I want to say that all of the files should keep the end of lines the way they are. So this thing minus text for everything. So git, please do not touch any end of lines. Do not convert end of lines. How do we close this thing? Let's kill all of the processes. Where are processes? Git and process 3 and process 3 and wish. Is such a thing? Nope. Okay, so this is probably the IntelliJ project, I'm going to guess. IML file. This is the source code, the only file that we're probably going to use, the .java file. I'm not sure what this does. Or this. In here it says that we're using the QtJambi library, which will be added to the class path. Git ignore in git ignore and my git attributes. Okay, so initial commit. I do not have these things configured yet. Let's do that. Can't we copy this thing? Yes, we can. So I just press Ctrl+C on this message box, which looks like a standard Windows message box, and the standard Windows message boxes have the functionality of when you press Ctrl+C, if the message box is focused, you go Ctrl+C and it will copy to the clipboard the body of the representation of the message box, including the title bar. Escape to clean. What is this? Don't do such a thing. Who knows what happened? Okay. commit. So now we have one commit where we edit the files and the text of the commit is initial commit. Great, now we can edit as we like this file. Okay, so let's see what we can do next. We can create a Q widget, which is a window. So let's do that. Q application initialize args. Let's create Q widget. And no owner. And then we show it. And then exec static. Let's see if this is the new way of running it. Let's run it directly. Okay, and it shows a Qt window, which is this one. Okay. Next, let's add more Qt widgets to this Q widget, to the window. Okay, so we have the widget, which is actually the window. We have the show, which is going to run the main loop. Now we need to add more widgets. So let's add some buttons. Okay, and we'll put these buttons in a layout. Okay, so let's do this. Let's create the push button. New Q push button, yes. How many possibilities do we have for the Q push button? There's no parameters, which sets null as its parent, and then there's the overload with parent as a parameter. Then there's one with icon and text and no parent. There's icon, text, and parent. There's just text with null parent, text and parents, all of the combinations possible for text, icon, and parent, from what I see here. So let's go with the overload that is with text and parent. So this one. Or can we split this thing? Like this. No. Like this. Okay. Okay, so new Q push button with text. So the text is exit. And the parent is this parent. The same thing for the other 3 buttons. Different texts, so there's write and there's copy. And there's also a layout. So let's go with where are you? VBox layout, this guy. Okay, VBox layout. Let's see what overloads exist for the constructor. So there's a parent, the null instead of parent, and calls the super immediately. So it's an overload of box layout. There's also a QDeclarative constructor, which is for what? I know what declarative means. Maybe it's for QML. I know. Okay. And then we need to put all of these GUI widgets, all of these controls, one inside of each other. So there's vbox dot add widget, the first button. There's vbox add widget, the second button. There's a vbox add widget, the third one, which is button copy. Okay. Then widgets need to be connected with vbox. Okay. And this was renamed to widget. Everything should run now. Let's run it without debugging. So you can resize the window. The window starts with a default value for its width and height, and the buttons have a default width and height based on the default width and height of the text of the buttons. Okay, resizing works correctly because the whole body of the window is just the QVBox layout, and the so this means it's a layout that has 3 rows, just 1 column and 3 rows. So there's 3 cells. In each of the cells there's a Q push button. When we resize the window, we resize the VBox layout, and that resizes all of its cells, and all of its cells have a Q push button, so the Q push buttons get resized. There's no event implementations when we click on the push buttons. Okay, what happens if we change the type of layout? We can go from QVBox for vertical box to Q horizontal box. So this thing needs to be put into places, and that's it. If we keep the name of VBox, then the application will run, but then there will be a layout with 1 row So this is the row, and 3 cells, 1 cell, 2 and 3 columns, 1 column, 2 columns, 3 columns. So there's 3 cells, 1 row, 3 columns. This is a minimum width. This is a minimum height. And the resizing resizes the width of the buttons, not the height of the buttons. Okay, let's now look at the signals and slots. So QtJambi is a wrapper over the Qt framework for the Java programming language. It knows how to use the Qt meta objects or metadata. It knows about signal slots, how to connect those. And let's see a simple signal and slot connection. So before we actually start the main loop, we'll need to set the connections. So button exit, the event is named clicked, and we connect that thing to either a slot 0, slot 1, etc. So we're going with a object receiver and a string. Let's look at the overloads. So this overload object and then string. Okay, so we want to call widget.close. The Java object is widget, and then we need a string with a certain syntax. Okay, let's see if this thing works. Control S and run it. Exit actually closes the entire application because it closes the widget, which is actually a Windows main form. And once all of the forms of the application close, the application itself will stop. Okay, next we'll create another Java source code file, which will be named main window in uppercase M. So now we're going to move the parts that are about the main window from main.java to main window.java. So this thing will extend the class QWidget, this thing. Let's create a constructor. How do we do that? Let's create the constructor by hand. Public QWidget. Public widget, not QWidget. How are you doing? Main window. Correct. Okay. So the parts that are about the main window is the constructor, then creating other Qt widgets that are going to live on the main window. Layout, and the signals and slots. So this part. Okay. So this is a main window. This is a main window. Okay, which we show. So main window, new main window, show, and then exec. Okay. So this is a Java class named main window, which inherits from QWidget. So this is also a QWidget. Okay, these are constructed correctly. The layout is correct. Okay, and now we'll add two more event implementations. So there's a button right. These, and in here we have methods from the current class. So let's create those. On button right clicked. So I create two private methods that just write to the terminal. And this one is button copy. Okay, Control S, let's run this thing. If I press the exit button, it's going to go main window dot close. Main window inherits from QWidget, so it will do QWidget dot close, and that will close the only window of the application, which will close then the application. Okay, let's run again. Right. So to the standard output, it wrote right, which is the implementation of this method. And copy has the wrong text, so let's put in here the text copy. Control S. Okay, now instead of writing to the standard output to the console, which is hard to see because this is a graphical user interface application, it will probably not show the command line. It just if you started from this application from the command line, which being a graphical user interface application, you're probably just going to click on an icon to start the application, so you will never see the terminal where the GUI application is writing text. So let's have a label on the window, and we'll make sure that these two methods edit that label. Okay, so we have 3 buttons, then we have a label. Okay, and this label has the constructor where the parent is set to null, has a constructor for a parent and window flags. Which window flags is a QFlags. So in Qt you have an enums of type flags. In C# you have such a thing. In Java you do not have it. So QtJambi exposes the enum, which is this window type. So the Qt enum becomes a Java enum. But in Java there's no easy conversion from int to enum and from enum to int. So there are the public methods in each enum, which is a value, which converts from enum to int, and a way to go from int to enum, which is this constructor. This is private constructor. So there's the public static resolve. So you would go window type, the private static resolve, so dot resolve, and then the integer value such as, I don't know, 4. So that would be, there's no 4, let's go 3, so that would be dialog. So dialog has the associated value of 3. Okay, and then on top of the enum, which is named window type, you have QFlags of window type. And QFlags implements bit operations over enums, so intersection and bit operations. Combine and clear a flag. Okay, so we're going to set the parent here, which is a Q widget, and this inherits from Q widget. Let's see how it looks like. So it's in here, but it has the empty string as value. Okay, so now we need to replace the implementation of the two events, system out print line, with actually editing the label. Which we cannot because the label is not a member of this window. LBL result, the identifier, is available only in the constructor of the class. So we will need to make this a private data member field of the class main window. Okay, so let's do that. Control C. Private Control V. And this thing is defined in the class, not in the constructor. In the constructor is being created. Then it's being added to the VBox, and then it should be available in the two private methods. Okay, set text, and then we have the texts. Copy. Let's run this thing. So write has replaced the empty label with the string write, and it has made space for the label because the label is one cell on the fourth column on the first row of the VBox. So once the label became wider, the VBox became wider, so the entire Q window, which is the Windows window, became wider. Okay, so this shows us how to extract Java to another Java class. So one class per Windows window. Then this shows us how to use signals and slots. We have 3 buttons and a label. This shows us how to use the label. There's a set text method for the label. And now we're going to also add the way to enter text, which is the Q line edit. So for that, we will have a Q line edit like this. Line edit. Let's name this otherwise. So name line edit equals new Q line edit, and it needs the parent, which is this. So the first control should be a line edit. Then there should be the right button. Then there should be the label. There should be the exit and then the label. So we do not want the copy button. And exit should be after right. Okay, so line edit, right, exit, label. Okay, no button copy, no button copy. So no implementation of the event on button copy clicked. Okay. And we want in here to read what the user writes in the name line edit and get the text from the name line edit and set the text into label result. So line edit should be a member variable. Like this. So the order is name line edit, write, exit. And then label. We still have the close button working. We still have the button right working, but the implementation of the event handler is different. In here, we take the name line edit text and we put it into the text of the label. So there's both get text and text. Get text goes return this dot text, of course, the method, and the method goes to the QtDLL native const function. This thing. Okay, so there's get text, which is the getter. There's set text. Not really. Okay, so the text method is marked as QtPropertyUser. Okay, so it's the same thing if you go text or get text. So we went with text. Let's look at the implementation again. So main window extends QWidget. In the constructor, we create all of the Qt widgets necessary. We put them into the correct VBox, so HBox layout. Let's rename this thing. Box. Okay. And then we have the connections, signals and slots. Just one method that we need to implement for this connection. The other method, close, is already implemented when we inherit from QWidget. Close. This thing. Okay, let's see it running. So I'm going to go with John. Right, so it replaces the empty string, that's the value of the label, with whatever is the value of the edit box. Line edit. And exit continues to work the button. Okay, so let's create a backup of this thing so we can edit it. Instead of a message box, now we create a main window. The main window has push box, label, line edit, and QHBox layout. Line edit and label. So which file did we change and what did we do? We did the line edit and the label. Okay. And now we'll edit the main window in order to present a group of checkboxes. Okay, so we'll have a VBox layout, which is going to be the main box. Then we have a group box. Group box, so group boxes have a text on the top left. What do we have there? We have options, the text, and then we say that the group box is a child of the main window, QWidget. Then we'll create the checkboxes. QCheckbox checkbox 1. Okay, text and parent. Three checkboxes. Okay, and then inside of the group box we have a layout. Layout. Okay, and all of the checkboxes will be inside. All of the checkboxes will be inside of the inside group box layout. Okay. Okay. The layout of the group box will be the inside, and the main window will have the group, the layout main box. And the main box has just one widget, the group box. Like this. We do not need these things anymore. Let's see how it looks like. So there's a main window which extends QWidget, which is a Windows widget window, which is this one. Has a layout which is the main box. The main box contains just one thing, which is the group box. The group box has just one layout, which is called inside group box layout. And this layout is vertical, has one column and 3 rows. In each of the cells, there's a checkbox. Okay, so group box does not make sure that so this is not radio buttons where you can have just one selection. You can have multi-selection in checkboxes. Okay, so this was checkboxes. Now let's see radio buttons. Okay, so all of the, where are you? Let's replace all of the checkboxes, Q checkbox with a radio button. What's the shortcut? Edit, replace Ctrl R. Okay, so all Q checkboxes become Q radio button, match case, whole word, replace all. Okay, and then checkbox becomes lowercase radio button. Without whole words, just match case. Place all. Okay, let's see how it looks like. Okay, so we have replaced checkboxes with radio buttons. You cannot have multi-selection. Resizing works correctly because we use layout. Okay, let's back up our work. It works so well. So this is the version with radio buttons. Okay, next we're going to use a multi-line edit box, multi-line whatever label, which is going to be a Q list widget. So for that we have a QVBox layout, and then we have a list. Okay, so the layout will be main layout. The main, let's name it layout. Okay, has the main layout, has 2 widgets. There's a list box and buttons. So let's do the list box. List widget. Okay, the list widget will have just the parent. Let's see how it looks like. So a list widget that stands inside of a box layout that stands in a Q widget, which is a Windows operating system window. Okay, and then we need to put buttons in an organized way. So that's Q horizontal box layout. Bottom layout. Okay. And in there we have a line edit and a push button. So we want to add items to the list. Okay. So we want a label, which is the label for the line edit. The parent. Then we have the edit box, which is called QLine edit. Name. This just has the parent. And the third thing in the bottom layout is the button to take whatever is inside of the line edit and append it to the list widget. Okay, the text is add and the parent is this. Okay, we need to put all of these things inside of the bottom layout. Okay, this thing and that thing, and let's run it. Okay, it totally does not look okay. So we did not add to the main layout the bottom layout. Add widget, you cannot add a layout because layout is not a widget. So we need to go add layout. Ctrl S. And now the graphical user interface looks okay. What we want. In here we will add items, which will be read-only. In here we enter names. And then pushing the add button will add the text in here into the list widget. So let's see how that is done. Okay. So we will need to add event handlers. So that's the button. Clicked, connect this, and we're going to create a method, private void add button on. Clicked. Okay, so this text in here. And then on the event implementation, we want to add things to the list widget. The list widget is not available here, so let's make it available. Remove the declaration from the constructor and create a private field. Okay, so list widget dot append add item string. We cannot access the line edit because it exists only inside of the constructor. Text. And it works. Okay, let's back this thing up. List widget. Okay, the next step would be to do this, which is using QtJambi UIC.jar. We're going to convert a file that's created by the designer tool, the forms editor, Qt Designer. So those files have the extension .ui and are XML. It's going to convert a .ui file to pure Java source code file. So let's do that. Let's create a form first. Do we have Qt files here? Yes, we do. Qt Designer. So let's create an application. A main window. We are going to edit the main menu with file and quit. So file and quit. Okay. Then we're going to add a main control on the main window. Let's make this window a bit smaller. Input widget. Plain text edit. Okay, and we're going to lay this thing out. Layout in a grid. We're going to run the form if possible. Let's see. Preview. Okay, so it has a main menu, a status bar is resizable, has these 6 dots here, and then in the main menu there's the file and quit submenu item. Okay, let's save this file. We're going to put it in the project that we're working on, which is this thing. Let's have a side src, a directory named, for instance, input. And this should be main window. So it's case like this, main window. Okay. Save. Let's look at the file. So it appeared in here, main window.ui. It's an XML file. Okay, so using this, we're going to create a Java source code. So let's see how that is done in the documentation. So it says that we need a command line like this one. Let's prepare inside of the text editor. Java library path to Qt libraries. What's the separator for the Java library path? Like this. So we need the Qt. It's in path. Will this thing work? Yeah, let's try without. So no Java library path. -p, this is 652. This is 652, but I do not have this file yet. Then the module QtJambi.uic. Output src doesn't matter. There's no package. And the full path to the UI file. This thing. So we need QtJambi UIC. So says we need a platform dependent QtJambi UIC native, and the QtJambi UIC jar file. How did we get those? So they're sorted alphabetically. QtJambi UIC. This thing, versions 652, not Java doc, not sources, but a actual jar. QtJambi in here, and we need another one, which is this guy. QtJambi native Windows x64 versions 652 jar save. Okay, let's see if this is enough. And we're going to run this thing from the directory where QtJambi is. So temp this and this. These two files, QtJambi 652 jar and QtJambi UIC 652 jar, exist in the current directory. This is the entry point module or something. It will create a subdirectory src in here, and then the full path. So it says that you cannot go QtJambi jar and then colon. What's Java -p doing? No. Module QtJambi not found. Just a second. So on Windows, the -p, so -cp is the class path, searching for directories, zip, jar files. Whereas -p is the module path, and the module path is separated by semicolon, probably on Windows. So it might be that this is a separator on non-Windows, and semicolon is the separator on Windows. So the correct command line is this one. Let's see what it does. So it creates a subdirectory. Let's delete this subdirectory. Paste again, enter. It succeeds, creates a directory. In there, there's two files, mainwindow.java and UI mainwindow. Let's look at those. So this is auto-generated from mainwindow.ui. It creates all of the widgets that are defined in here. So there's a Q main window, a Q menu bar, a Q grid layout, a Q plain text edit, Q menu, Q status bar, etc. Here. and then it sets all of the properties. So for the action quit, there's a text quit. So sets all of the properties. Where are you? In here. It did not use tr, so it used the long form for the translation, for the method that does translation, so internationalization, which is from package io.q.core, from application qcore application, and from class qcore application, and the method is called translate. Okay, and the second file is a file that creates a Java class that has as member the UI main window. This thing. Okay, but we can use the UI main window Java file directly, so we rewrite this thing. Let's see how it's done. Okay, so let's close the Qt Designer. As part of the project, we already have in the subdirectory input the main window.ui, so we can re-edit the .ui file whenever we want using the forms editor Qt Designer. And then we'll need to run the command line again. So this is the command line. Let's not lose it. And put it in the main.java. Convert this.ui to this.java. Okay. And we're going to take the UI file, Control C, put it inside of the src directory. It doesn't have any package specified. You usually have a package. You don't just use the top level directory. Okay. And now in main window.java, we can use this class. So this will actually be a private field. And in the constructor, we'll create okay. And then there is an important function inside this object, which is called setupUI, which requires a main window, which is this. And change first parameter from QMain window to main window. What's the error? Okay, let me find out what the error is. Yep. So the error is that this method, how do we go to definition? Requires as parameter a QMain window, which extends QWidget. So main window needs to not extend QWidget, but QMain window. Okay. Let's run this thing. It says illegal Unicode escape. It's a comment. Okay. Identifier expected, so you will need to have a package. We do not have one now. Okay, so this is a native C++ window. Everything's native and C++ in here, what we see on the desktop. But the actual native objects were created by us creating Java objects, which are backed by native Qt objects. While Qt does not do anything yet, but we can add text and we have a status bar. Okay, let's set up the close button. So UI main window dot, we want the, we did not name, did we? The exit widget. Let's look. This thing action quit. Q action quit. So the Qt designer has named the C++ object correctly, which is action quit, without me having to actually edit it. So it took the text that I've entered in the forms editor and named the object correctly. So great. Okay. Back to the IDE, and this is action quit. Okay, and we are going to implement a connection signal slot. When the action is triggered, connect this and the close method on the QWidget. So again, this main window inherits from QMain window, QMain window inherits from QWidget, and QWidget has a quit method, a close method. This one. Let's see it in action. Let's edit something. File, quit, and it works. Okay, so we can do more customizations after setup UI runs. So the not recommended way is to just enter inside the UI main window .java and edit things, but then this file is auto-generated. You should edit the input file, so main window.ui, and then regenerate to get this file, UI main window.java. Or you can have, as I know, code behind after the method setup UI, which again comes from an auto-generated file. Then you still can customize the widgets that exist in here. For instance, I don't know, you can change the title of the application. So UI main window dot, what is this? So it has a central widget, a status bar, menu bar. There's a main window which is parent. You know, you can change the text of, I don't know what. This thing. Okay, so now the main menu of the application has just one item with the text I have edited file in it. So this is a way to customize the UI that's edited with Qt Designer, and then you get a .ui file, and then you convert that to a .java file. The other way to do it is if you edit the UI file in Qt Designer and then run the command line again. So this command line. So let's do it like that. I want to, I don't know, change the window title. So for that, we have the input file, which is going to open with Qt Designer by default. Nope, it opened with Qt Creator. It's kind of the same thing. Qt Designer recent, no recent, close. Okay, file open, and then this thing. Control V. Okay, and we're going to change the title of the application to be so main window, the text, window title. This guy should be Notepad. Okay, save, close everything. We don't have a Git commit yet, because this way we would have seen the changes of the main window.ui file. So that's a problem. And now we can run the command line again to convert the .ui file to Java. So we need to be in this directory in QtJambi, which is this. And we're already in here. Let's see that the command line continues to work. Okay, it has put the file in the wrong place, which is in this directory. We need to place it in this directory and make it compile by removing the empty package. This thing. Okay, let's compile everything in IntelliJ IDEA. Just run it. And now the title is Notepad. Okay, so this is about it. We can install QtJambi. It depends on Qt. We've installed QtJambi 6.5.2. So we need to use the Qt online installer to install version 6.5.2, so the same version of the Qt framework. We've installed the Qt framework in the default location, which is c:\qt. So this is the most important directory from Qt. Then we have installed QtJambi by just downloading from Maven build artifacts. So we needed, for now, we just needed 4 Java jars, which is QtJambi, QtJambi UIC, and the native correspondence for Windows AMD 64. Okay, I've installed the Java JDK version 20. I've installed IntelliJ IDEA in here, where? In system-wide, in add remove programs. Where are you? This guy. And the project, IntelliJ IDEA project, is in here, so it's called Untitled. I was forced to create this file. The gitignore was created correctly automatically by IntelliJ IDEA. This is a file from IntelliJ IDEA. I'm not sure what it does. Then there's the hidden .idea directory from IntelliJ IDEA. There's the out directory where build artifacts are created, so class files, there's no jar files. And the src directory where we have the important main.java file, which is the entry point to the executable, to the process. Then there's the UI main window file, which is generated using QtJambi UI compiler. It converts .ui file to this file to Java, pure Java source code, just one class. It even uses Qt translation infrastructure. And then there's a main window simple minimal Java class that needs to inherit from QMain window, because that's what UI main windows method setup UI expects as a parameter. Then we need to create the UI main window object and call the setup UI method on it. Then we have access to all of the objects that are available in Qt Designer. So a action, a widget, a grid layout, plain text edit, menu bar, menu, and status bar. We can do everything, anything that we want with those in here. So after we call setup UI, including we can connect signals and slots. As long as we have access to the Java object, to the Java objects that wrap all of the C++ objects that we have edited in Qt Designer, we can set properties, call methods, and connect signals and slots for all of the member variables. All of these are marked public because we are going to use from the outside an object of this type. It makes no sense to make the member variables which represent Qt widgets private, because then you cannot even connect a signal slot to these Qt widgets. So this is it for QtJambi. What remains to say is to read the rest of the QtJambi GitHub web page, GitHub project, including the wiki. Okay, so QtJambi has documentation inside of the README file, and then it has a www directory where you can see a small number of markdown files, but you will need to read all of them if you want to actually use QtJambi. So you start with modules, where you get the list of Qt modules that have Java wrappers. So QtJambi ActiveX, I'm not sure what that is. You need to make sure to download both the platform agnostic jar and the platform specific jar file. The most important module is QtJambi, which wraps Qt Core, Qt GUI, Qt widgets. If you want QML, then you're going to need more. Who knows how many? So Qt QML, Qt Quick controls are probably going to be used if you're going to create a QML application. There's even wrappers on top of Qt Multimedia, so you can create your own audio player or video player. Positioning. SQL. And including Web Engine and Web Engine Quick. So you can have a QML Quick application written in Java that has a web engine, so a web browser control inside of it. This is WebView. Okay, including Qt PDF. So many important Qt modules are wrapped for use in Java. Okay, then you have how to develop in Qt Java, which is what we went over. Then you should read more about getting started with programming for C++ Qt, which is this thing. Create your first applications. Okay, there's properties that you can set for the Qt libraries, such as how to log, where to log. Okay. You can set the theme of the Qt application, XML debugging. Okay. And you will end with the differences. So what's different between QtJambi and C++ Qt applications. And you also have how to deploy a QtJambi application depending on the platform that you're targeting, including Android. So either you use a long command line and you have a ton of jar files in your directory, or you can create, for instance, for Windows, you can create an executable file that will contain all of the needed jar files and DLL files, etc. Needs to be located in the same directory as Qt core. So you just create a directory structure and the exe file will find the DLLs. Okay, for that there's a jar from QtJambi which is called QtJambi deployer. On macOS you need to make sure that you're setting the main thread parameter when you're running the Java application. Which is this thing. -x start on first thread. Okay, so the things that are specific to QtJambi are defined in this file. There's this shutdown extra method. This is the way you create a Q application. How you inherit from QCore application, QGUI application, Q application by using this initialize overload with the constructor as parameter of your current class. Okay, so many Qt string types are mapped to the native Java string type. Also const char pointers, the C default, the C programming language default type for the string const char pointer. Okay, there's a QString class in Java that represents the mutable QString. And there's method toString, which so in order to create the QString, probably you need to call the toString method. Okay, we talked about enums and flags. Enums in Qt, Java enum. On top of the enum, there's functions to convert from and to integer with the value method and the resolve method. And there's extensible enums, and then there's flags. So you go combined or the flags constructor, or just the constructor. The flags static method to do the combination with this operator. So the equivalent in this would be in C++, and one of these three in Java. Okay, pointers and references, array pointers, function pointers. Okay, methods C++ Qt methods that return QList. So QtJambi container wrapper classes are fully compatible with Java containers. QList implements the interface Java util list. QMap implements Java util map. So that means that if the Qt function returns a QList, that's also a Java list. And if it accepts as parameter a QList of something, it has an overload for a Java container, so Java native container, not a QList, QQ, QHash, etc. And then QVariant is the object type in Java. And there's a QVariant Java class for type management functionalities. Whereas QString, where are you? So QString is only for conversion and formatting features of QString, of the C++ class. So there's a Java class named QString, which provides data conversion and formatting methods similar to the ones of the C++ QString type. Overloads are named, so plus equals is the method .add. This is the method intersect in Java, so this is C++ code, this is Java code. So C++ operators become Java methods. The methods .add, .intersect, .assign, .inverted, .divide. QObject parenthood avoids the garbage collection to delete the child objects of a parent even if no more references to a child exist in Java. That's why we can do, and we did, construct inside of the constructor. We're creating like this. So we're inside the constructor. We're creating a QPush button, and then that QPush button exists for the remainder of the duration of the process. So this QPush button named btn_write will only get deleted when we close the application, even though we create it inside of the constructor of QMain window, and the constructor exits immediately, still the Java garbage collector could not delete this button because of this Qt parent relationship. So QObject parenthood avoids the Java garbage collection to delete the child objects of a parent, even if no more references to the child exist in Java. So that's that. QPointer, QWeak pointer, QScope pointer. So all of these are really advanced. You need to read this page in its entirety, comprehend it, but these are things that you might not encounter on your day-to-day work with QtJambi. There's a signal when a Qt object is about to be disposed. You need to mark some methods as being Qt uninvocable if you're extended from QObject, like this. Not invocable. This method is not invocable because it's private. All of the public methods are invocable by default. All public and non-static methods in a QObject-based class are invocable by Qt, plus non-public void methods. So this is a non-public but void method, so you need to mark it as Qt uninvocable. So QtJambi, when you have a Java class that inherits from QObject, QtJambi automatically creates meta object metadata and a corresponding QMeta object that has the Qt metadata, so properties, signals, slots, invocable methods. There's the signal slot mechanism in Java. A signal is a final member variable of type signal n. There's signal 9, 1, signal 2, up to signal 9. You cannot use Java primitive types, so you need to use boxed Java types, so the ones that start with an uppercase, such as integer, instead of this primitive type int. You can connect it using many overloads of the connect method. You can go stage changed.connect, so the connect method of the signal, or you can use QObject and then the static method connect. You can emit signals with the signals method, with the emit method. There's properties. QtJambi automatically detects properties. So if you have a Java class that inherits from QObject and has two methods, getFoo, setFoo, then it considers that there's a property foo that's exposed by QtJambi in the meta object as Qt metadata. So there's property notify, there's property reader, property writer, and then there's also the property resetter, which does clear text changed. So if you have all of these methods in Java, then in Qt metadata you will have a property named text with reader, writer, resetter, and notify signal. Okay, there's additional features for Qt properties, such as the one that we saw previously, which is Qt property user. There's Qt property bindable. The classes defined in Java are fully compatible with Qt's meta object system. QMeta object for type. Gadgets are non-Qt object-based types with invocable methods or properties. Cannot have native signals. Threads, you can use thread, which is from Java lang thread, or you can use Qt thread. Qthread. Instead of Qthread wait, the method is named Qthread join. Okay, many ways to start a thread. There's a Qthread for a Java thread, like this. Or a Java thread for a Qthread, like this. QMutex, QReadWrite lock, QSemaphore, QWait condition are provided. QMutex locker, QRead locker, QWrite locker, QSemaphore releaser are not provided. And you should use try finally instead, like this. Try lock, finally unlock. There's no QAtomic, integer QAtomic pointer, so you need to use Java atomics. Qt has interfaces, which are classes with pure virtual functions. QtJambi uses Qt interfaces as Java interfaces. The keyword there is implements instead of extends. Okay, there's this IMPL, says all interfaces have a nested default implementation class named EMPL. So you can extend the nested implementer class. So instead of saying class myRunnable implements QRunnable, you can go class myRunnable extends QRunnable.impl. Okay, there's the Qt resource system. So you need RCC. Files with the Java program. So this needs to be deployed with your application or put inside of jar files. You can put any resources directly inside of a jar. Class parts resource QRC. There's internationalization by the method tr, l_update. So you need a .pro file. It generates a file with extension ts. You open that with the application Qt linguist. You translate it, then you call l_release. It creates a file with extension .qm. And then inside of Qt translator, you load that qm file. User interfaces, we've designed them with Qt Designer. Creates .ui files. You can either use UI loader to use the .ui file directly, but then how do you access the individual fields inside of the UI file? Or we're using QtJambi UIC, which we did, which creates native Java file. And then it has support for QML. You can define classes in Java and you export them to Qt meta object, and then the QML source code will see it. You need to initialize the Qt modules. Qt quick view, set source and then show. You can register from Java types that can then be used from QML source code. QML register type. In order to be available from QML, the Java class must have a declarative constructor like this, which is what we saw. With that constructor that we didn't know what QDeclarative constructor is. And must inherit from QObject. Okay, and then you've created from Java the class message, and then you can use it from QML. You can additionally register singleton types, instances of objects, uncreatable types, interface types, extended types, attached properties, similar to how you can tell the QML engine from C++ that these additional symbols are available to the QML source code. So all of the Java classes that you want to use in QML, you will need to call QtQML QML register. Or you can export an entire Java package with hundreds of Java classes to the QML source code with QML types register package. You can specify the package version. You're going to use Java annotations in order to annotate identifiers, Java identifiers, to be exposed as QML. So QML element, QML edit in minor version 5. Transferring QObjects from Java to QML. The QML engine might change the object's ownership. Okay, so it would be interesting to see how QtJambi does QML applications. You can bundle your custom Java QML classes into a jar file and provide it as QML modules. QtJambi provides the jar import plugin. So you create a file QML dir with the content module and then plugin jar import. And the jar. So you can create QML modules using jars that contain jars. This is not QDir, this is QML dir. Okay, so this is it. This was how to use the Qt framework from the Java programming language using QtJambi. Thank you.